Have you ever stopped to consider that everything we think we know about the universe might be fundamentally wrong? What if the theories we've held for decades, even centuries, were just a glimpse of a deeper reality that we have yet to fully comprehend? Imagine a universe where space and time aren't what they seem, where the universe is eternal, boundless, and unchanging. A universe where the idea of time itself could be an illusion, and reality might be far stranger than anything we've ever imagined. In this extraordinary reality, the universe has no beginning and no end. The questions we ask about the birth of the cosmos, the expansion of galaxies, and the ultimate fate of everything we know could all be irrelevant. These mind-bending ideas aren't the stuff of science fiction, they are rooted in one of the most debated theories in modern cosmology, a theory that has challenged some of the deepest assumptions about the nature of the universe. It's called the steady-state theory, and it was proposed by three brilliant scientists, Fred Hoyle, Herman Bondi, and Thomas Gold, in the mid-20th century. The steady-state theory argued that the universe was not a temporary system that began with a Big Bang or will eventually wind down to nothing, but instead an eternal and unchanging entity, with new matter being created constantly to fill the void left by the expanding cosmos. This was a bold new vision of the universe, one that ran directly against the grain of the widely accepted Big Bang theory, which argued that the universe had a singular, definitive beginning. But what inspired such an audacious idea? How did these three Cambridge scientists, who had spent their careers working on some of the most advanced concepts in astronomy, come to believe in such an unorthodox idea? Surprisingly, their theory was not born from equations or observations of distant galaxies, but from an entirely unexpected source, a 1945 British horror film. Yes, you heard that right. The steady-state theory was, in a way, inspired by a ghost story on the big screen. This seemingly strange and whimsical origin story might hold the key to understanding not just this theory, but perhaps some of the greatest mysteries about the universe itself. The film in question was Dead of Night, a British anthology horror film that was released in 1945. The movie was structured as a series of interwoven short stories, each telling a different eerie tale of the supernatural. The stories were all connected by a common frame narrative that featured a man named Walter Craig, an architect, who finds himself at a country house filled with strangers. As he mingles with the group, he realizes that each of them seems strangely familiar to him, even though he has never met them before. As the evening progresses, each person shares a strange and eerie story, stories involving ghostly apparitions, cursed objects, and other spooky events. The tone is haunting, yet there is an air of uncertainty about whether the supernatural occurrences are real or just figments of imagination. The film's most chilling twist comes at the end. Walter Craig, the protagonist, realizes that all of the strange events unfolding before him are not happening in the present, but are part of a recurring dream he's been having. The eerie tales are simply the products of his subconscious mind, and the entire evening, including the people and the stories they've shared, are simply figments of his imagination. As Craig awakens from the dream, reality returns to normal, but the final moments of the film leave a haunting question lingering in the air. Did the events of the dream truly happen, or were they just part of an alternate reality, another layer of existence that we cannot perceive? This unsettling exploration of dreams and reality struck a deep chord with Fred Hoyle, Herman Bondi, and Thomas Gold. After watching the film, they each had a strange, almost mystical experience, a feeling that there might be more truth to the idea of an eternal and unchanging universe than they had previously considered. They were struck by the notion that the universe could, in some way, be like the dream in Dead of Night, a continuous, eternal state, where time as we understand it is not real and the universe simply exists, perpetually renewing itself. In the months that followed, the three scientists developed the steady-state theory, a bold vision of the cosmos that challenged many of the prevailing assumptions of their time. The steady-state theory proposed that the universe was both infinite and eternal, with no beginning and no end. According to this theory, as the universe expanded, new matter was continuously created to fill the gaps left behind by the expansion. In this way, the universe could appear to be changing, but in reality, it would always maintain a steady, unchanging state. This theory was based on the idea of a perfect cosmological principle, which stated that the universe is the same everywhere and at all times. Whether you looked at the universe a million years ago or a million years in the future, it would always appear largely the same, with galaxies, stars, and planets continuing to form and evolve. The steady-state theory was a direct challenge to the Big Bang theory, which had gained widespread acceptance in the scientific community during the 1920s and 1930s. The Big Bang theory proposed that the universe had a singular beginning, a cataclysmic explosion that sent matter and energy flying outward, creating the universe as we know it. This theory was supported by the observation that galaxies appear to be moving away from each other, suggesting that the universe itself was expanding. According to the Big Bang theory, the universe began from an incredibly hot and dense state and has been expanding and cooling ever since. But Fred Hoyle, Herman Bondi, and Thomas Gold were not convinced. They argued that the evidence for the Big Bang was not as conclusive as it seemed, and they believed that the universe had always existed in roughly the same state, with new matter constantly being created. For them, the idea of an eternal, unchanging universe made more sense than a universe with a beginning and an end. After all, how could the universe simply begin from nothing? Where did the matter that exploded in the Big Bang come from? These questions troubled the three scientists, and they saw their steady-state theory as a more consistent and elegant explanation of the cosmos. However, despite the appeal of the steady-state theory, it was not universally accepted. In fact, it faced significant opposition from other scientists who supported the Big Bang theory. The debate between these two competing theories became one of the central controversies in cosmology during the mid-20th century. The steady-state theory had some strong proponents, but it also had its critics, particularly after the 1960s, when new discoveries began to provide strong evidence in favor of the Big Bang theory. One of the most important discoveries came in 1965, when Arno Penzias and Robert Wilson accidentally discovered the cosmic microwave background radiation, CMB. This radiation, which was detected as a faint glow coming from all directions in space, was later interpreted as the afterglow of the Big Bang, an imprint of the heat that was left over from the universe's fiery birth. The discovery of the CMB provided strong evidence that the universe had a beginning, supporting the Big Bang theory and dealing a significant blow to the steady-state theory. But even with this setback, the debate did not end. The steady-state theory had made testable predictions, as the philosopher of science Karl Popper had pointed out. According to Popper, a good scientific theory is one that makes clear, unambiguous predictions that can be tested and potentially disproven through observation. The steady-state theory fit this criterion, but the new observations made in the 1960s, particularly the discovery of the CMB, contradicted its central premise, that the universe had no beginning and no end. Despite this, some scientists held out hope that the steady-state theory might still be viable. The 1960s also saw the discovery of strange and enigmatic objects called quasars, extremely bright and distant objects that emitted vast amounts of energy. Some theorists argued that the existence of quasars could be explained by the continuous creation of matter in the universe, a key component of the steady-state theory. These observations, along with other strange phenomena, suggested that the universe might not be as simple as the Big Bang theory suggested. Could it be that the universe was both evolving and eternal, in ways that we didn't yet fully understand? By the 1970s, however, the evidence for the Big Bang theory had become overwhelming, and the steady-state theory began to fade into the background. It was clear that the universe had a beginning, and the idea of continuous creation of matter was increasingly seen as unfeasible. Yet the steady-state theory's legacy lived on, influencing later cosmological ideas, particularly those involving parallel universes and the multiverse. Today, the steady-state theory is largely considered to be disproven. However, some of its concepts continue to resonate in modern cosmology. The idea that the universe might be part of a larger, eternal cycle, one that is not bound by time in the way we traditionally understand it, has found new life in contemporary theories like the cyclic model of the universe and ideas about the multiverse. Could it be that the universe is not a one-time event but part of an infinite cycle, one in which galaxies are born and die, only to be reborn again in a different form? Modern research, such as observations from the James Webb Space Telescope, has revealed galaxies that are far more advanced than they should be according to the standard Big Bang model. Some of these galaxies appear to have formed less than 200 to 300 million years after the supposed birth of the universe. This has led some scientists to suggest that the universe may be much older than previously thought, or that our understanding of its origins may need to be completely rethought. Could these discoveries provide support for the idea of an eternal, unchanging cosmos, as envisioned by Hoyle, Bondi, and Gold? Is it possible that we are only beginning to scratch the surface of understanding the true nature of the universe? As we continue to explore the cosmos, new discoveries will undoubtedly challenge our existing theories and assumptions. The steady-state theory may no longer be the leading explanation for the universe's structure and origin, but its audacious ideas continue to spark new thinking in cosmology. And who knows? Perhaps, like the characters in Dead of Night, we are only beginning to realize that the universe is far stranger, more complex, and more eternal than we could ever have imagined. Science is about the search for truth, not about being right, and the truth may be far more mysterious and profound than any of us can currently understand.